Okay, we just got done doing systems of systems of inequalities, which if you recall was where we have two inequalities we graph on the same grid, and then we look to see where they're the same. So where do they overlap? Remember, they have to be overlap or be in on a solid line that bounds the double shaded area. Okay, so all we do with systems of inequalities is graph. We're about to start systems of equations, and for systems of equations there's like 4 different methods, and I know you're like, why do we have so many methods? Remember, we're building a toolkit of ways to make sure that we get the answer with the least possible computations, because remember, every time I say 5 minus 2, I run the risk of saying that's -3, which is wrong, by the way. Or, I run the risk of saying that -2 times -3 is -6 when it's actually +6. So every time I do an extra computation that I don't have to do, I run the risk of making a simple arithmetic mistake that could lead to me getting the answer wrong. So I'm trying to give you all kinds of different strategies that you can use to get the right answer. Now, this particular strategy is best used when we have something that's easy to graph. So say they give me a graph, or they give me 2 equations that are in a graphable form. And that graphable form it could be point slope form, but it probably won't be. Probably if they give you something that's in a graphable form, like if they give you 2 equations in slope intercept form, you can stick those things in your calculator and look at the graph of them. So anytime they give me something that's really easy to graph, then I'm going to want to use method 1, which will be graphing. And then if I look at the graph and I still can't quite tell where the answer is, I have another method that we're going to learn on Thursday that will help us with that. It's kind of like a backup plan. All right, so we're going to start with the situation. We're going to handle our our highlighting a little bit differently. And the reason we're going to do that is because, first of all, these are slope intercept form equations. I know that because it says I have some amount per plus a fee. So when I have a rate and a fee, that means slope intercept. On the ones that we did on our prior notes, on our notes from the last one, those we had we kind of had 2 rates. We had $3 per pound, 50 cents per pound. We had like a whole bunch of stuff about asparagus, a whole bunch of stuff about bananas. I know, remember our bougie, our bougie caveman? Yeah. So this, when we do standard form, this is how we're going to want to write equations. And it gets even more complicated when we're writing standard form systems. But for now, to kind of help us keep it straight, since we're just learning, what we're going to do is anytime we see, they're asking us, so the question is, which company should she choose? So I'm going to look for the companies. Well, the first company I see is Quadrant Music. Okay. So anytime I see Quadrant Music, whatever color I use to highlight it, I'm going to highlight it in that color to help me keep track of it. Because again, they might ask me where the lines cross, but they might ask me something else, and we're going to see some examples of that here in a minute. Okay, so all that to say, let's get started with this. When we graph a line, now when we graph an inequality, we got to know about shading and the boundary line, but when we graph a line, all we need to know are slope and y-intercept. So I want you to write an equation and then tell me what the slope and y-intercept are. Okay, so the equation that I wrote for this, and I think I'm going to write in pencil, is, because y'all know I make mistakes, is y equals 2x plus 1. And then again, they said Quadrant Music, so I'm highlighting Quadrant Music Inc. Okay, and now they want me to graph this. So I want you to take a minute and graph it, and then when you're done, just check and see if we got the same graphing. If we didn't, y'all fix it, okay? Because remember, we want good notes. All right, so take a minute and do that right now. Okay, this is what I got when I graphed it. Now, should you have connected these points? Remember, we look at, so again, they tell us here, I'm just going to underline this, they say Y is the total cost of a CD, X is the number of songs purchased, okay? So remember, when I decide whether or not something, when I connect points, I look at the X variable, at the input. Can I purchase half a song? No, I cannot. So that's the reason why I didn't connect these points. But in general, when I do a system, I kind of don't connect those points anyway, because I want to be able to see where they're crossing. So when I do a system, I usually, whatever color highlighter I use for that one, that's what I'm going to connect the points in, even though this is a discrete situation. In fact, you know what, I'm going to continue this up a little bit more, just because why not? Just to really get a good idea of where the line goes. Because again, remember, when I have a continuous, I wouldn't connect the points, but the reason why I'm connecting it now is because I want to see, I'm looking for where these lines cross, so I need to be able to see where the lines cross. Okay. Next question they ask me is, write the linear equation to determine the total cost of a CD if songs are purchased from Slope Recording Company. Okay, so now I have a new one, and Slope Recording Company is right here. Oh my gosh, that is such a dark, wow, okay. I think I said that last time too. They charge $1 for each song plus $5 for materials for a CD. Okay, so I want you to real quick write an equation and then identify the slope and y-intercept for that. And then graph it and come back and see if we got the same thing. Well, actually, let's check the equation first. Okay, I got y equals x plus 5. Or if you put y equals 1x plus 5, that's totally fine too. And again, I like to put the number here because, you know, then I know I'm going to have to graph it. My slope is 1, my y-intercept is 5. And I'm sorry if I forgot to say it. Up here, my slope was 2, my y-intercept was 1. Okay, I want you to take a second and graph that and then check and see if we got the same thing. All right, so this is what I graphed. Yours should look like this. Again, just to help me see it a little better, I am going to connect this up. Let's see. I'm going to connect these again with my blue highlighter because that's what color I'm using for Slope Recording Company. Again, I'm not saying that line should be connected from a discrete and continuous standpoint. I'm saying that I want to be able to see the line. Okay, so let's look at this. It says if Cutie Pie purchases blank songs, the cost will be blank at both recording companies. So both is my key word here. So I need them to have the same number of songs and the same number of, and the same amount of money. Well, what I look for is, you see how right here where they crossed, I put an X? That right there, that is where they're the same. We call that point where they're the same, we call this the solution. Call this the solution. Okay, so where they cross is a solution. Well, this solution happens to be 4, 9. So when they buy 4 was the X is songs, 4 songs, the cost will be 9 on the Y, which is $9 at both recording companies. Okay, so the next question is, if they purchase, how many songs will they pay less for at Quadrant Music Company? So I want you to think about an answer. Again, I just want you to pause and think for a second. How many songs will they pay less for? All right. I think, so at Quadrant Music Company, so Quadrant is the pink line. So you see how right here they're the same? Well, they're paying less. They pay 1 instead of 5, 2 instead of 6, 3 instead of 7, 4 instead of 8, and right here they're the same. So at 0, 1, 2, or 3 songs, they pay less at Quadrant Music. Okay. If she purchases blank songs that cut, well, again, I forgot to highlight, go Maggie, at Quadrant Music. Okay. So at Slope Recording Company, when will the cost be less? Okay. Well, if I look, once I get past 4, 9, here it looks like it's like 10 and 11, and then 11 and 13. So anything, and this is how many songs? 5 songs. 5 or more songs. Now let's be honest. Do we know she's not going to record like 5 million songs? I don't think anybody's recorded 5 million songs, but feel free to Google fact check me. Okay, she's not going to record like 5 million songs. Okay, so 5 or more. So, you know, so I want you to do, what I want you to do is I want you to think. I want you to stop, think. Which company should you use? And I want you to be able to justify your choice. Okay. I'm going to say that answers could vary here, meaning you could have a variety of answers, and I want your choice. You justify your choice. I might ask you about it tomorrow. Which company should she use? Well, I guess it depends on why. I mean, if she's recording like a single, she's probably going to want to go with Quadrant Music because she's only going to have one side and a B side, right? She's only recording a couple. If she's recording like an album or an EP, she's going to have 7 to 15 songs. She's definitely want to go with Slope Recording Company because as you get past that 4/9, where it doesn't matter, then she's gonna get a better deal. Okay, so again, that's the thing about systems. They don't just ask you where they're the same. Sometimes they ask you who's got the better deal. Like when would you use one? When would you use the other? So sometimes they'll ask you about a better deal. So it's not just important that we understand where they cross. We have to understand everything leading up to them. Okay, now, real quick, I want to ask you a question. Should I have anything graphed over here? Pause for a second. Yes or no? No, I should not. And the reason I should not is because X is the total, is the songs purchased. Can she buy negative songs? No. So technically, I shouldn't even have anything graphed over there. I don't love this graph for that reason. But again, if I was just graphing the equations, all those values over there would work. So if all I had was 2x plus 1 and x plus 5, then yeah, I would totally be over here. And I could have a solution over here. But since this is a real world situation, I can't have a solution in that part of the grid. Okay, so you should have your own justification for that one. Now let's talk about this part here. It says the intersection is, so where do they cross? The intersection is at 4, 9. That's where they cross. So is 4, 9. This means the x value of blank and the y value of blank simultaneously satisfy both equations. Answer for me which one that is. Okay. Hopefully what you said was an x value of 4 and a y value of 9. Now, it says verify algebraically by substituting the point into each equation. So what we're going to do literally is this is the same thing that we did to test points when we did inequalities. It's the same exact point testing strategy where we plugged it in, we plugged in the values here, and we checked. Actually, I probably have an even better example of that, but where we checked to see if they worked. Okay, so that's what we're going to do. So we're going to say y. Now we have to be careful. Carefully substitute. So I have 9 equals 2. So y is 9, x is 4, plus 1. And I can put that in my calculator. 9 equals 2 times 4 plus 1. That's not it. Plus 1. And it says that's true. Yep, or I can work it out and I get 9 equals 8 plus 1. Is 9 8 plus 1? Yup. Okay, we'll do the same thing here. 9 equals 4 plus 5, because this is 9 is my y, 4 is my x. Yeah, that's true. So this is true. Remember, just like with a system of inequalities, it has to make both of the equations true. It can't just make one true. It's got to make them both true. So the intersection point of these graphs of these equations is the solution to this system of linear equalities. So the first thing we can see is one solution. Now let's go down here and let's look at what this one is. Okay, so we'll see if we can figure this out. Now we have two different companies. Oh my gosh, we have Discrete Music Designs. So the cost of a CD at Discrete Music Designs is $3 per song. Okay, so I want you to write me an equation for this. Write me an equation for this situation. So we're just looking at discrete right now. Okay, write me an equation. All right, my equation is y equals 3x. If you put y equals 3x plus 0, that's okay too, because you're acknowledging that the y-intercept is 0. Now remember, it doesn't mean there's no y-intercept, it just means the y-intercept is 0. Okay, so now I want you to graph that. Alrighty, this is what I graphed. Hopefully your graph looks the same. I don't know why my line is so light, but whatever, here we are. Let me make that a little darker. Next thing I want you to do is, I want you to, it says now, the next one, it says Linear Tunes Unlimited. So for a CD at Linear Tunes Unlimited, there's a materials fee of $4 and each song costs $3 to record. I want you to write an equation for that one. Okay, my equation was y equals 3x plus 4. Again, if you put y equals 4 plus 3x, that's fine. Just remember the slope is in front of the x. The slope is the coefficient of x. It's not the first number you see in the equation. So the slope's not 4, it's 3. All right, I want you to go ahead and graph that. Alrighty, this is what I got for my lines. Okay, so I want you to just look at these lines and I just want you to tell me how they're related to each other. Like, you should be able to describe what these lines are. Yeah, they're parallel, right? So they're not gonna cross. So remember, we said the intersection point of the graphs of these equations is the solution, but these are never gonna cross. So when the lines are parallel, they never cross, so there is no real solution. Okay, why did I say no real solution? That's a problem for another day. Okay, but there is no real solution. So you might say no real solution. You might say no solution, but no real solution is better. Okay, so I'd like you to start saying no real solution, but it is possible you'll see no solution. No real solution is more precise, and we'll talk about why later. All right. Okay, what I want you to do is I want you to take a minute and I want you to find equations. I want you to do your highlighting and your equations for these two problems right now for the next one. All you're doing is doing the highlighting and writing the equations. We'll graph them together in a minute. I want you to check them before you write them. All right, so what you should have here is these two equations. So either one of these is fine, and technically either one of these is fine, but this one's hard to graph. So I would go up 6, then down 5, and then start graphing my rise and run. As you can see, I had a situation here. Please don't judge me, or do, whatever. Okay, so I'm going to start graphing these. I want you guys to, I think I asked you to graph. Just take a second and graph this one if you haven't done so already. Alrighty, here is the first part of my equation. Now, I'm going to graph the second one with you because I want you to see what happens here. Okay, so when I graph this one, even if I graph it like this, I start at 6, I go down 5, and I start graphing it. Or if I graph the simplified version, I start at 1. Well, they're the same there. I rise 4, run 1, they're the same again. I rise 4, run 1, they're the same again. Every single time I graph a point on this line, it's identical to the line that's already graphed. So what this means is that I have infinite solutions because everywhere I put a point on this line, they're the same. It's almost like a double shaded line. Okay? So what this means is that there are infinitely many solutions to a system of linear equations whose graphs are the same line. So you might see infinitely many. You might see all real numbers. Okay, so these are the types of solutions that we might see. Now this again should all sound very familiar to you, and we're going to kind of summarize that up tomorrow.